here we are again. Got ourselves a straight 6 donkey stomper this time around. Biggest issue is high SWR with amp on. Other issues are the relay in the driver amp stays keyed after PTT is released. There's also a, can't read it, to go along with the amp. The amp being returned for repair, and the 2 pills I replaced. You can call me blah 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 blah. Okay. So it sounds like it's oscillating, sounds like it's got a high SWR pass through, is what I'm hearing out of the notes. I could be wrong. It does look like a couple of the transistors have been replaced. The solder work here and here is completely different than the solder work here and here. So when we go over here and we look at the output circuit, and we see this lead here has gotten so hot it's almost unsoldered. I mean, it's still kind of soldered, but I mean, it's hanging on by a prayer. If it would focus, y'all could see this. Look at that. I mean, it's just barely touching. But this lead here attaches to this circuit here. So we're going to go ahead, we're going to disconnect the lid. And obviously the output combiner ring needs to be rebuilt. And I mean, there's a couple things I want to test, like this output cap. Look, once again, I cannot make this clearer. It's not my job to talk shit, it's just my job to fix the box. If this output cap gets hot, which happens, and breaks down and falls out of value under heat, which happens, that can cause this section to fall low, which will cause these 2 resistors, this one and this one here, to heat. Okay, and we could have a problem. I want to reflow the solder here. I want to test this cap, and then if we go and we look down here, if we look down here, we'll see that this thing is barely soldered on itself. I want to check that cap too before we go any further. Just want to check the caps and make sure they're within tolerance. This should be about 150. Okay. So let's take a quick look at that and see what we find. It doesn't look to be bad. This is true. Okay, so that's falling off at a predicted rate. Okay, so we know that this isn't like the worst. Please note I'm barely heating this, you guys. It's so cold that I can hold this with my fingers still. Even the metal clips are not that hot. Okay, it's just falling out of tolerance with a little bit of heat. So that doesn't seem to be that bad. Let's go look at the input capacitor really fast. This is a 180. $182.4, so that's within tolerance. So if we find the caps are all in good condition, then we got to figure out it's something with the tune on the box, which is causing it to oscillate. And I think he uses 390s in this setup, if I'm not mistaken. Yep, it's a 390. So that's way out. Well, not way out, it's 12 puff off. We'll grab its parent partners around it, and we'll see what we find. But nothing screams to me, here's your problem, out of this mess. So let me reflow this solder work and make it so everything's actually physically connected. And yeah, we'll move on to the next step. So now, let's test. Let's see what we got going on here. If we got a short to ground, which we do not. Good conductivity through the coax, no short. Okay, so we know it's not the mini coax, so it means the RF's making it to the combiner. Why does this have such a high turn count to each one of the output transformers? It's a little odd. So, come on. It's got a whole nother wrap in it doesn't need to have on each one of the output transformers. Input transformer wrap count's good, but output no good. Okay, so we got a couple things we got to change, that we're gonna change. I want to check this cap and this cap also, this cap and this cap also. I want to change the number of turns in the transformer so it's electrically resonant. And let's go look at the pass-through, like RF's ability to go in and come out of the box. So we're looking at the ability for the RF to go in this connector, go through the relay, and then come back out and go to the 50 ohm dummy load. Okay, so we got out the network analyzer, and let's zoom on in here and look at what we're working with. So right now as it stands, at 27.025, we got a 1.5 SWR, which is not bad. I mean, it's not bad. We're looking at, from 0 megahertz basically to about 53 megahertz, which is not bad. That's not a high pass-through SWR. It's really not. If we add, I think about 15, let's see, what does a little capacitance say? Yeah, we add about 15 puff to it. 10 or 15 puff, I bet you that will drop even more. We'll get it a little bit lower. Let's try a 27. Still too much capacitance. Let's go lower. We're talking about splitting hairs here, but let's grab a couple 5s and see if we can tweak it down just a little bit lower. There we go. I would take 2 5s and twist them together. That'll get us 10. And that's going to be about as low as we get it. You know, all readings on, I don't care what kind of meter you got, anything below 1.1, at 1.0 is a unicorn number. And all we're doing is we're tuning to the, you know, the half a quarter watt or whatever it comes out of this thing. Yeah, see what I mean? We're just tuning to the half or quarter watt is all that we're making reactant to the circuit. So it could be that I go and I add this cap and it looked good on the tester when we had the cap in here, right? With me holding it in place. And then we go hook it up and that's going to change a little bit. It happens. And when you go and you run your radio at a couple watts, it might change even then, again, a little bit. So I tell guys all the time, your network analyzer is just to help get you started and keep you and your electronics safe. You want to test underneath whatever power you're going to be working with. I get this all the time. Man, I hooked up my MFJ and it's perfectly flat SWR, perfectly flat. And then I go and I hook up my amplifier and I turn on my amp and I put 2,000 watts out there, and then all of a sudden my SWR jumps up and it's through the roof. It's through the roof. I'm like, well, what's through the roof? It's a 1.8. Your SWRs are not through the roof. You need to readjust your antenna for your new power level. What? What? My MFJ says it's perfect. Look, an MFJ is just a device built by man, and it's flawed. Believe me when I tell you it's flawed. And who's to say that the reference of that MFJ, just because the frequency on the front of it says X, doesn't necessarily mean that's where it's working. So, and there's huge voltage differences. Huge voltage differences between the quarter milliwatt that this thing is putting out, 250 milliwatts, this thing's putting out, versus a couple kilowatts. So we'll call that a win. That's good enough. I could add 1 or 2 puff to it and slide this dip back and forth, but in real world applications, that's about as good as you're going to get. It really is. Okay, let's redo some solder work. Okay, so I thought, well, I should probably err on the side of caution. And I went ahead and I put the cap back in it, the output tuning cap, the input transformer swamping capacitor, the input tune cap, put that all back together, soldered this all back together so it's actually attached, and thought I'd give it a little test run and see what we get out of it for power. It's 1,000 in peak here, 1,000 in average, and a 5-watt cell universe. Hello. So we're going to put about 30 watts into it. Hello, audio. Hello. Get about 500 out of it. Hello. Not too bad. Input tune is hello. Not too bad. We're at 15 volts. Hello, audio. Of course, perfectly flat. Hello, 1 2 1 2. All right, look through the pass-through tune. Hello, perfectly flat. Going through it. So let's come up in the drive a little bit. Let's grab the bench 955. Which is the black coax. Turn the amp back off, turn that radio off, turn this one on. Okay, let's go zip in here real quick. Hello, audio. About 90 watts worth of drive. Hello, audio. Hello, audio. About 850 watts, 900 watts of power. Hello, audio. Hello, audio. Hello, audio. Okay. Now let's go up here. Sorry, got myself lost for a second. So we're going to look at 2 meters now. We're going to look at the faceplate of the striker, and then we're going to look up here at this meter here. Hello, audio. We start to go up in power, our input reflex starts to climb up. Here it's showing me a 3, and up here it's showing me about a watt, or 2¼ watts worth of reflex coming back. So what that's telling me is that the RF is coming in from the coax connector, going through the relay, coming through our inductor coil, past our capacitors, is getting split 3 ways, and it's bouncing back. So every 10 watts that we're putting into this thing, we're about, every 20 watts going in, peak power, we've got about 1¼ watt coming back, which is bad, because we're supposed to go even higher in drive with this. And a little bit higher in drive, so the higher we go in drive, the higher the input reflex is going to be, and this should be relatively low at about 90 watts, 95 watts worth of input. How we normally would make compensations for that is we'd adjust these capacitors here. But honestly, I think it has something to do with this over amount of inductor going on there. I bet if I pull a wrap out of here, it's going to dramatically change how this amplifier works. Okay, so we took a turn out of each one of the output transformers. Everything's exactly the same. Voltages are the same. Drive levels the same. Hello, 1 2 1 2. Hello. Same drive. Hello, audio. Picked up 200 and something watts. We went from 800 to almost 1,000. This is the part that I wanted you guys to see. Just close to about 2½ watts before, with an SWR of 3 on the front of the striker. Hello. So now we've taken over half of our input reflect out of the equation and made a radio very happy. Now we can go play here with this set of capacitors here. We're going to adjust this and get the input reflect down even lower. So that's what he meant by high SWR with the amp on. Because I bet you when he's running his radio into this, he's seeing an incredibly retarded amount of SWR. Well, was, anyhow. So okay. Smaller amount of turns equals more resonant and more power out with the same amount of drive. To me, that's a win and a lower input SWR. All right, let's go play with the input tune. Okay, so after some simple tests, we figured out that it wanted more inductor, wanted more unihenry. So we went ahead, we modified the coil, added about 2 turns to it, and this is our end results up here. Check this out. So everything's the same. You guys are gonna get a kick out of this. The striker meter is so freaking twitchy, dude. It's crazy. I mean, I've had it where the input reflect is 0 and this is still showing me 2. Okay, so that's just a hair over ¼ watt reflect. Check this out. Hello, audio. Hello, audio. So the meter is totally happy. Now, let me explain this. If I added more capacitance, I can actually get the input to 0 where it doesn't even move. 0. But down here on the striker, it's showing me that we have an SWR of like a 2. And then when you modulate, it drops to 0. It doesn't matter where the dead key's at on the radio. That's another thing with the striker meters. If you don't have the dead key up a little bit, like a watt or 2, man, it doesn't know where the hell it's reading. And it's going to give you all kinds of weird... It's going to say, oh, SWR is infinite, even though the SWR is only like a 1. Hello, 1 2 1 2 1 2 1 2. Perfectly low. perfectly low. Let's come over here, take a look at the spectrum analyzer. Still dead on track. 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Yeah. Dead nuts on track. Okay, well, that resistor's chooched, that resistor's chooched, this one's burned up, so I'm going to build a new combiner ring for here. I want to upgrade these to metal clads, just so we can. I don't have to worry about it after it leaves here. I know that they're going to stay in one piece. Is it going to make any watts out the pipe difference? No, I just, me, mentally, in my own mind, will feel safer about things. So, that was our problem. Didn't have any capacitance on the pass-through. It had too low of inductor on the input, not enough capacitance. The output, of course, the stages were set up wrong, so yeah. All right, let's bring this the rest of the way home. Okay, so we got the output system all put together. We replaced all the output capacitors with metal clads for my personal well-being. And with the 490 hitting it, or the 955 hitting it. Hello. We're still up there in power quite a ways. Like, change this a little bit. Hello. There we go. Hello. There's our 1,000 watts, no problem. Our input SWR issues have been addressed. Let's come on over here. Let's disconnect the 450 or the 955. Let's grab the 490, which is about 80 more watts worth of drive. And I bet you we'll be in the 1,300 watt range somewhere in there, 12 to 1,300 watt range someplace. Hello. Oh yeah. Hello. 1, 2. Hello. 1, 2. Hello. 1, 2. I should really cut the limiter out of that 490, get a little bit more average out of it, but I can't think about cutting limiters anymore. I'm not a big fan of it. Was for a long time. Okay, so now we're on 2X. So the big hash mark between the 40 and the 60, right there, is 1,000 watts. Hello. Hello. 14. Hello. Hello. Audio. Hello. 14 some change, which is just about right with this amount of drive. Let's put the stack down on 1X. Let me show you drive. Hello. About 180, 185 watts going in, making 1,400 coming out. This thing is perfect. I'm leaving it alone. Well, my man, you're all fixed up. I'm going to reattach the fan and test the fan, but I don't think anybody on here really cares. Oh yeah, it's a good sun-on, 3.7 watt. Little sun-on fan. So off to the races running. I'm going to lock this tube down, put a little bit of glue on this and hold it in place. But anchor and tits, good to go. Gentlemen, my name is BBI. And I got about 1 million more of these I got to go through and get done. So I'm on a hurry, I'm on a mission. I'm on a mission from God, as I said in Blues Brothers. Got a couple more of these I need to get done at least today. So on that note, I'm going to run away, and I appreciate every single one of you. I'll see you. Click, click, click.